So it's part 2. We're looking at how we add input validation. So the very first thing I'm going to do is set a variable so I'll initialize a variable that starts off as true. And if we encounter any errors, we'll toggle that value from true to false. So we basically are going to, we have to replace these 6 calls. We've got to change them rather than using convert. In each one, we need to call try parse instead. We need to attempt to convert each value to a number and then evaluate whether that worked or whether it didn't. So how would we replace, let's kind of take this one. What would we change here on the first one? We'll just kind of do it through one, and then we can pretty much copy and paste to do the rest of them. How are we going to replace this? So,
make a statement for the try parse.
oh. That is not the label, but it's the what object instead. What value are we checking? Yeah, we're checking our first text box. We'll try to convert it to a number. If we do, result in our COMP1030 variable. Obviously, the names of your stuff will probably be different than mine. Oops. Sorry. So we're going to try to convert our first value to a number. If it works, we'll store that value. So if this fails, what should we do? So the user did not give us a number in that first text box. If they didn't give us a number, we're going to print beside that first input. And if we did get a number, then we can do this. So if they gave us a valid number, we're not actually checking here the numbers between 0 and 100. First, we just want to check and make sure we got a number. And now this line I can take out. So this will check that that first box is numeric. If it's not, we'll tell the user to give us a value between 0 and 100. If we did get a valid number, well, now we can go ahead and figure out, did they get an A, B, C, D, or F in their first course? So we basically were going to replace these other 5 statements with this exact same logic. The other change I'm going to make down here, we got to change something down here, down at the bottom. When we're calculating the average grade and the overall letter grade, what change should we make here? We don't have to take anything out, but we want to add something in that highlighted section. What should we add? Right now, this code runs no matter what. Do we want it to run in all cases? Right, we only want to do this. There are no errors. So there's no point trying to calculate an average if we don't have. So we're just going to move that stuff inside of our if. Thanks, Jaden. So I'm only checking the first grade, but if we run this now and I don't put in a number in my first box, we should get a message beside the first grade, and our program shouldn't crash because we're not going to try and do a calculation. We'll just try it out and see. So I'll enter grades and everything. So that's the result we want. We can still calculate any grade, but down below, nothing happens down here. The one other check we now need to add here is if I do this. I put in a number that's outside of my range of 0 and 100. We're not checking for this, so our program's still allowing people to give us this information. So first we're checking that they gave us a number. And if they didn't, we're asking for one. So right now we only have two scenarios. We got a number or we didn't. We have one other condition in here we need to check. What if we got a number, but that number isn't within our acceptable? So in between our if and our else, we need an else if. So if it's less than 0, here's the C# symbol for or. We can just repeat these lines. So here we didn't get a number, here we got a number, but it's either a negative number or it's more than 100. In either case, we want to tell the user, give them an error message, and turn OK from true to false. And then we basically are just going to repeat that if statement 5 times. Which isn't super efficient, but it should do all of the validation checking we need to do. So we've got a number, but it's not within our range, so we don't calculate the average and we've shown the user an error. It's not the most efficient thing in the world for us to repeat this 6 times. But it will work for now until we talk about arrays. We could then rewrite this code after we know what an array is to make it more efficient. So basically, I'm going to copy that And then I just have to change my variable names and text box and label names. And then it should check all 6. And then we'll get rid of, it will replace those 10 lines, which right now just assume that we got numbers every time. So if I just change the course codes, I need to make sure I change them everywhere. Now it will check both my first and my second grade. I can actually use Visual Studio's handy. We can do a find and replace just in one section. So if I highlight this section and click on Edit, Find and Replace, I can replace any instance of 1002 with 1051 just in the lines I've picked. This highlighted selection, and click Replace All. Oops. Broke. Okay, maybe not. It's putting in line breaks, which are no good. I'm not going to do the other 3 right now. I get the idea. Whoops. So I think I validated my first box and my third box now. I would just repeat that for the other ones. I'll finish doing my copy, paste, and replace later. But if I have all valid values, then things still run properly. So one of the things we do when we're testing any application is go wherever there are inputs and try and put in inputs that don't make any sense and see if we can crash inputs. That's actually what I'm doing right now with my student project who's working for the research department. There's all kinds of forms. So I'm going in and making sure I can't put in invalid inputs anywhere, that I can't crash those pages, and that if I put in the wrong stuff, I get descriptive error messages guiding me to put in the right kind of information. So it's tedious, time-consuming work. But it's an important part of what we do. Anybody have any questions about how we validate what we're doing here?
that the only way to close out a range? Numbers. 0 to 100.
With the or? Good question. Well, we do have a min value and a max value. So we may be able to use those. That's probably the easiest way, is checking that way. May not be the only way, probably the simplest. Fair question. So I'll give you guys your assignment 2, either the end of class today or the start of class next week. It'll be due just before the holidays. Okay. Not that big. It's an application with one form on it. Not that much different in scope than the grade center, but part of that is going to be input validation. But obviously you're going to have to make sure that all the inputs on the form have proper values. We're not going to want to do any processing unless we know the user's given us a complete set of values and all those values make sense. So I will finish this on my own time. I'll do it later today, and then I'll repost it in here. I'll call it assignment 1 solution with full validation, so you'll have a copy of it. But I would suggest trying to finish it on your own would be the most helpful. I'll put mine up as a reference for you. Okay. So the other thing I want to start to talk about today is the concept of arrays. A few people probably know what this is. In fact, I think I saw a few arrays used in assignment 1. Arrays are a really important programming concept. It's an object we use all the time in any kind of programming language. What the heck is it? And how is it related to the images I've got here on this slide? Could you define an array in really simple terms? For anybody who's worked with them before. Joel? Okay. So we've worked with, different variables, first name, last name, email, password. In this case, we have a bunch of related variables, right? In our grade center, we actually do. So how would it relate to the things you see here? Right, so here we've got Dart. Each Dart is basically the same, right? So this holder holds a collection of a similar kind of item. And it would be the same in any of these, right? So an egg carton doesn't hold different things. It holds 4, 6, 12, 18 of the same thing. Right? You don't have an egg in one holder and a block of cheese in another spot. It's not how the carton's designed, right? It's the same shape. Same here. You get one size of stapler. So you get a collection of the replica of the exact same item. Same here, right? This is going to hold 4 batteries that are all the same size. So an array is really just a list of similar kind of items, is the way to think about it. So one of the things that makes an array easy is when we have a list of stuff, we can go through it using a loop. We can say start at the beginning of this array and loop through until we get to the end. So for example, when I go into Blackboard and I click on the grade center, there's an array on there that selects all the students in this class and displays each of your names and student numbers in a list. So each student, you all have certain information in common, right? That Blackboard has. Everyone has a first name in there, a last name, a program, a student number. So there's certain attributes that all of you share. So we can create a list, and the definition of one student is kind of the same as students. So if we think about our grade center, so arrays can hold different things. And we can have an array of students. A simple array, would just be a list of numbers. So this is kind of our grade center translated into an array. So rather than having 4 separate variables called like grade 1, grade 2, grade 3, grade 4, we could just make one variable called grades. And these brackets indicate that it's an array, it's a list. Rather than holding a single value, it holds a list of related values. So in this case, we're creating a list of grades, and each element in the array holds a numeric value. And we're saying that this array holds a maximum of 4 different values. And then this is how in C# we could assign each one of these grades into a different spot in the array. So all arrays kind of work the exact same way. So it might be an array of numbers, could be an array of strings, could be an array of dates, could be an array of eggs. We'll come back to that. So if you think of a deck of cards, really a deck of cards is an array, right? Every card has 2 attributes. What 2 things do we need to know about any card for playing cards? There's 2 things on every card we're interested in. Yeah, so what's the suit and what's the number? But a deck of cards is nothing but an array. And every card has those 2 things in common, right? It's got a suit and it's got a number somewhere there. So a simple array looks like this. We just have a list of values. Complicated array would be kind of something like this, because we've got rows, but then we also have columns. So this is almost 2-dimensional, like a table. And you'll work with this structure a lot next semester in your database course. We have a list of items, but each item has a whole series of individual properties shared. So we'll play around with this a little bit. Now for this, I'm going to write some C# code just to play around with how arrays work. But rather than doing it within Visual Studio with the editor, we just want to use a code-only window. And there's actually a neat little web application we can use. So I want you to go here. Actually, I'll put the link on Blackboard for you. Sorry, I'll throw it in our folder for today. Just give me a second. Make sure I've got the right link. You can browse, or I'll put the link up here. So this is a place where you can actually write C# code in your browser, and it will run it and tell you if it runs successfully or gives an error. So if you open up your Weekly Learning Week 8, you can click on the C# browser test, or you can just type the URL, which is csharppad.com. So you get this little window. So just like Visual Studio, it'll check our code as we write it, and then it will execute our code. It'll show us any error messages, or it'll show us whatever we want to display. I want to create an array, 6 grade values. I'm going to make an array that's an integer. Again, it's like a variable, but it holds Many values. Whoops, I don't think I did that right. Sorry. No. So by putting the empty brackets here, we're telling C# this isn't a variable, because a variable can only hold a single value. This is an array instead. It's a list of related values. So this creates an empty array. It's kind of like building an egg carton to hold 6 eggs. And now we want to populate each value. Record the first grade this way. Now, there's one very strange thing about working with arrays that takes a little while to get used to when we first start doing this. My first grade is grade 0. It's not grade 1. Why? That's exactly right. Okay. For some strange reason, and I can't really answer why it is, in every programming language, when we have an array and we start counting the positions always start at 0. So 0 is always the first position in an array. For a while, we'll get used to this. But it is bizarre and doesn't seem very intuitive. So go ahead and put in values. Let's say put in any values you like, doesn't matter. So here, one at a time, we're putting a different value in each spot in the array. So when we're done, we have 6 grades. Now, this is the long way of doing it. It's the most explicit because we're doing this, we're assigning a grade into each spot in the array one at a time. So this is a fair bit of work. I'm going to show you the equivalent. I'm going to click New Window. We can do this all another way. This is the quick way. Create an array of 6 numbers. We can also do it this way. So these are equivalent. I wanted to show you the first way because it's important to know that we start at 0. If we want to print out the grade that's at the first spot in the array, we're not using a label here. We have no interface. Matt, this you can do in your browser. So in here, we have this basically like a print statement. These little windows are, Microsoft calls them the console. So if we use the command console.writeLine, and click the Go button, it should display, this should display 60. So we've set up our 6 grades and we want to display the first value. That same line will still work exactly the same way over here when we do our shorthand. Works the same way. So it's the same result, regardless if we've set up our array in 1 line of code or in 7 lines of code. If we wanted to display the 3rd item in the list, how would we display it? We want the 3rd one. Right, so if we want the 3rd element, we're accessing 2nd position. So when I reference grades 2, it gives me this one. What will happen if we try this? If we execute that, we ask for the value at, this is really the 11th position, right? Because remember, we got to add 1. What do you think will happen? So the index, that refers to the position in the array. So outside the bounds, then you asked for a position that doesn't exist. You asked for the 11th element in the list, but the list isn't that big. So we don't have that. We can't give you that element. It would be like me referring to the 80th student in the room. Now, one of the other efficient ways to do this, one of the most efficient things about using an array is if we want to get or see all the values in it, we can now use a loop. And Zach, this comes back to what we were talking about earlier, right? You said, isn't there a more efficient way to check all of these values rather than checking them if one at a time? Yeah, if we put all the grades in an array, and with a loop, we can just check each one. And it doesn't matter if we have 6 or 600, right? That loop will run from the start of the array till the end. So let's try to display all the grades using a loop. And we could display each grade individually, but we'll need 6 lines of code and we'll have to repeat that line. If we use a loop, we can do this in 3 lines. And we're going to use a for loop here. So what number should we start at? Is it going to be 1 or is it going to be 0? What's the first position of our array? 0. So we're going to start at 0. Now we have a few options here. We could stop or we could continue so long as I is less than or equal to 5, right? Keep going. So we'll try it this way. Oops, that should be counter. So start at 0, continue to loop so long as we're at 5 or below. How much do we add to our counter each time we go around? Yeah, just add 1. So go from 0 to 1, 1 to 2. inside of our loop, well, what goes in here? How do we access the current position in the array? Tom? Right. So this should give us all 6 grades. Which it does. Now, typically when we use arrays, though, often the number of elements in the array aren't fixed, right? If we think of, for example, maybe we have a student who doesn't have 6 grades. Maybe they're a part-time student, so they're only taking 3 courses. Or maybe they have 5 grades because they dropped a course. So this loop works. It displays grade 0, grade 1, grade 2. But what if we want to change this? I'll do it over here. What if we want to make the number of times dynamic? Because we don't know how big, maybe the size of our array is going to change. It's not always 6 elements. So we want to say start at the first position and go into the end of the array. If that's 2 elements, fine. If it's 200 elements, fine. Go around 200 times, 2,000, 2 million. So how could we do that? Our array is called grades. Is there something in here that will tell us how big the array is? On the screen. Yeah, our array dot length. So these are going to give us the same results. We get all 6 grades. But why is this version, why are we going to more commonly use this version than the version on the left? Brenna? Yeah, because this code is going to run no matter how many elements are in the array, right? If I want to go and just add another element to the array, this loop is still going to work. However big the array is, it'll go around that many times. This one has been hard-coded and fixed. So this is only going to work without error if we actually have 6 elements in our array. But most of the time, our arrays sizes change. We looked at this. Right? When we're selecting, when the Globe and Mail is selecting the current articles, it's not necessarily 45 articles they display every single time someone loads this page. They just decide, show this article on the home page. So right now it might be 40 articles. In an hour, it might be 45 articles. So there's a loop on here that displays that. When you pull up someone's Facebook profile, it's the same thing. It's actually an endless loop. Through your news feed, it actually never stops. They just display a certain number, and as you scroll, they keep showing you more and more. Depends on how many friends you have. But that changes at any given time, right? Even showing your friend list, right? There's not a loop that goes from 1 to 50, because maybe you have 3 friends on Facebook. Maybe you have 500. And as soon as you add a friend or remove a friend, the size of that friend array of yours is going to change. So that code is going to be using this sort of a dynamic approach because those sizes of our arrays most of the time is not fixed. It usually changes. So that's how we do this with numbers. And it made sense. Our grade center, our grade array probably makes sense because that's what we built into our assignment. Let's try one where we have strings instead. So I'm just going to make a new window here if I can. So here's what I want you to do. Create this time a string array called fruit. Should I move it over here? Inside of your fruit array, I want you to populate it with your 3 favorite kinds of fruit. You can only eat 3 kinds of fruit the rest of your life, what would you eat? And those go in here, separated by commas, just like our grades are, except the strings are also going to need quotes around them, right? We don't need to put quotation marks around numbers, but we do need to put quotation marks around string values or text values. So where the cursor is flashing, enter your 3 favorite fruits. Each one is in quotes with commas in between the items. So put 3 values in here, separated by commas, and each value is enclosed in quotation marks. Kurt, what's the first element in your array? I can't even begin to enter that. Okay, what's the first element in your array? Okay.
Watermelon.
All right. So now what I want you to do is write a loop like this one that displays all of the elements of your fruit array. Use a for loop, start at 0. We don't need to specify how big the array is. We'll just use the length property. So that way we can put more stuff in the array if we want. And our loop will still execute. So use the loop we had on the left and try to get a list printing down of the values of your array. This in here. To run. We're almost done, folks. Do one more thing after this and we're done. Anybody want to suggest what this loop's going to look like?
For 32.
Yep. Okay, so we'll start at position 0. Yep. We can do less than 2. What if we want to make it more dynamic? Yep. As long as it's less than the size of the array. Yep. Okay. Yeah, and then what happens inside our loop? Yep. There we go. Okay, good question. Why did we use an integer here when our array holds strings rather than integers? Brandon?
Because like each value in the array is marked by a number, so that's what the loop's actually.
Right, so the loop is not concerned with what's in the array. The loop is simply a counter. Start at this number and continue to that number, right? And then what we do inside that loop is kind of separate. Does that make sense? Okay. So the last thing we're going to do is we're actually going to change one of the values in the array. So how, if we want to substitute watermelon, we want to take out watermelon, we want to replace it with tomatoes. Is Kurt like, or actually we should take out strawberries because tomatoes are first, right? They got to be the first thing. So how would we change strawberries to tomatoes? What would we do? Which element in the array do we want to change? Yep. Right. Okay, so how would we do it? That's exactly what we want to do. How do we refer to the first object in the array? Yep, square bracket. Right, so the first element in the array now I'm going to copy my loop again. So we're going to change, we're going to initialize it this way. So the first time around it prints strawberries, watermelon, bananas. Then we're going to change one of those values and then loop again and we get different results. So we can access any element. Here we're reading the values at each position, and here we're setting or changing one of the values. So the values in our array, they're not fixed. We can modify them. So part of what we're going to do next week in class is we're going to keep working with that assignment 1, the grade center, and we're going to do exactly what you guys asked. We're going to take those grades and create an array of grades, and then we can just check them and calculate the grade in a loop rather than repeating all that stuff, right? Because those grades, it's a list of related items. So rather than having the 6 individual variables, we can create that into an array to make our code much leaner, more efficient. We don't have to do all this repetition. So we'll work more with arrays next week. That'll be one of the things we're going to do with it. Okay. So I'll just copy this code and throw it up on Blackboard. And I will upload, once I'm finished, I'll upload my stuff back to Blackboard and we can work with it next week. Okay. If you haven't done Lab 4, it's not too late. You can still do it. Okay. Please submit it. I think I put on Blackboard, submit Lab 4 by Tuesday if you haven't. Yeah, the GitHub one. It's 5 minutes, really. Start of class next week, I'll also give you assignment 2. Okay, and you have a couple weeks to do. Sorry? It's not. If you want me to post it, I'll post it before then. I'll post it over the weekend. And we can go over and talk about it next week. Give me 1 sec to post this. I'll send out an announcement when that assignment is posted. Okay, so you'll know as soon as it's there. Please finish the Timbits or else someone take them home. They're gone? Excellent. Money well spent.
Doesn't have to do with this. It's just that I want to practice. What would I look for on Code Academy? Because Code Academy is better for me because it well, not as an example, but like I just need stuff put in layman's terms sometimes, like just like an easier way of doing it. Alex was great as a tutor. It's just that he was very hard to understand because he was way over my head. So okay. I asked them like if there was somebody that could explain it in an easier way. And they set me up with somebody called Daniel.
Yep.
Daniel, and do you think Daniel would be able to explain?
He's a great student.
Yeah.
You can look here. Let's just look here for a second. I think there's an intro C# course here.
Like the issue that I'm having is it's almost, and if I can put it in a visual way, it's almost like watching a video buffer, where it's like I'm a second behind the rest of the class because I'm kind of just looking at everything and almost like catching up as it goes and going like, aha, okay, now I'm getting it. Now I'm getting it.
Right here. So Code School. If you go to Code School,
I'll just take a picture of it.
Okay. So one of their C# courses is free. Try that and see what you think of that.
Yeah, it's just that's the only issue that I'm having. That like okay. You know, like I'm like even in class, like I'm getting where you're coming from when you explain it. But if I'm looking at it or it, like without that,